There are a lot of concepts which were proposed decades ago by think tanks of science. Concepts which seem simpler and interesting but not yet achieved. It was in 1665, through the book New Experiments and Observations Touching called, Robert Boyle articulated the dispute known as the primum frigidum, the source of all cold in this world, or the possibility of an absolute zero temperature. Absolute zero can be conceived as 300 million times colder than a refrigerator. Definitely, temperature implies motion. Hotter the object, rapid the molecules are, and the converse, colder the object, slower the particles are. Stated, absolute zero is the lowest temperature ever possible and has the value of minus 273.15 degrees Celsius. There comes the notion, absolute zero implies that atoms and electrons inside the atoms comes to rest. Believe me, absolute zero doesn't mean a complete absence of motion in a substance, but it implies minimum motion of a particle. I could back my statement through mere stating of Heisenberg's uncertainty principle. It states that if we know everything about where a particle is located, we know nothing about its momentum, and vice versa. If the electrons comes to rest, it means the position is certain. The certainty in position leads to large uncertainty in momentum. The large uncertainty in momentum implies large uncertainty in velocity, which means they are still moving. Or simply, position is zero implies velocity is zero, which is not true by uncertainty principle. Upgrading the explanation to next level, certain fluctuations in particles are caused by thermal excitations or temperature, and some others are intrinsically quantum mechanical. That is, even if you cool the system to absolute zero, only temperature component tends to zero, whereas quantum mechanical excitations still exist and electrons still move. The interesting fact is we haven't attained this temperature physically in lab, or it's almost impossible. But as I said, the think tanks of science already thought of this unattainable. Then why are we going behind this Herculean task of absolute zero? The minimum motion of particles resulting from absolute zero turns out to be cold atoms are very less sensitive to changes in surroundings and make very good detectors. And at the end of the day, we need more and more good detectors, more and more precise values, and we seek more and more perfection. Before winding up, Make Science in Seconds will provide you with shorter and simpler videos that will empower the science learner in you. Subscribe to our channel and watch our other videos to learn more science related contents in seconds.